Hi everybody, we continue review in Math 1324, 77 and 78. Just find the union of A and B. The union of A and B pretty much will be that. Everything in A and everything in B. So we will have, just write out everything. We have 4, 2, 8, 3, 5, and 7. Alright, 2 and 8 is 10, 3 and 7 is another 10, 4 and 5, that's 29. Right, now the intersection, this upside down U is the intersection, the overlapping of A and C. Overlapping of A and C is this, which have 2 and 8. So that is 10. Right. Now, use addition principle for counting to solve this problem. So the principle we're talking about here, the inclusion exclusion. So which is n of A union B or A or B. The upside down U can be meaning or is n of A plus n of B minus n of A and B. The intersection is n. So well, n of A is 40, n of B is 117, and this is union of A and B is 137. And now we solve for this. Just put that x. Now just solve for x. So x equal to, move x on this side, we have 40 plus 117 minus 137. So that's 157 minus 137, that's 20. Simple enough. At Southern State University, there are 239 taking finite math or statistics, 238 taking finite math, 184 taking statistics, and 23 taking both. How many taking finite math but not statistics? Right. Let's try to draw a Venn diagram here. We have finite math and statistics. We have 23 taking both. That's what we're sure of. And then 238 taking finite mathematics. So 238 have to minus the 23. So that is 215. And those 215 only finite math. Oh, well, that's what exactly what they ask for. Finite math only is 215. And then if we want statistic only, we take 184 minus 23. Right. But this one they ask for how many taking finite math only, so essentially what they're asking for is this region. So that's all we have. In a group of 42 students, 22 take history, 17 take biology, and 8 take both. So this we draw a Venn diagram. Have history and biology. A check both. So we always start with the smaller number, the overlapping first. And then history 22. So we have 22 minus 8. So that is 14. And then 17 tech biology minus 8. So that is 9. How many tech neither? So there are 42 of total. We're going to subtract everything in here. 42 minus 14 is 28 minus 8, 20 minus 9, 11. So we have 11. That tech neither. So 11. Right. A survey of 220 families show that, okay, now this has 3 categories, so that will be complicated. How many had the parakeet only? Interesting. Hopefully we have enough information to do the problem. Right. Right, so there are 3 sets. Right. A dog, a cat, and a parakeet. Right. 6 that have all 3, so always go with the smaller number, the overlapping. 84 had neither a cat or dog. So 84 on the outside doesn't have anything. Right. 28 have a dog and a cat. A dog and a cat is 28. But we have to subtract the 6 in total. That is 22. And 64 had a cat. And 83 has a dog. All right. So we have to be a little clever here. Okay. 64, if you minus this out, you have this portion here. So that is 64 minus 22 minus 6. So that is 40. 64 minus 22 is 42. Minus 6, 36. So 36 of that portion. And 83 has a dog. So dog is on this side. Actually, a dog. So we have 83 has a dog. Minus 22. Minus 6. So 83 minus 22 is 61 minus 6. 61 minus 6, 55. So 55 is on this portion. How many has a parakeet only? Now that's good. We have 84 here and all those numbers. 220 is everything. So bottom line is to get this portion here. We start with 220 minus the 84 minus the 55 minus the 36 minus 22 and minus the 6. So pretty much minus everything. 220 minus 84 minus 55 minus 36 minus 22 and minus 6, and we have 17. So that part is 17. That only have the parakeet. Right, now we go to this next type of counting problem. A restaurant has 3 types of crust and 7 toppings. How many different type of order you can offer? So three here times 7 here, that's 21. So 21 different type of pizza. Yeah, that's straightforward. Next, how many different sequence of 4 digits are possible? 4 digits are possible if the first must be 3, 4, or 5, and the sequence might not end with 0, 0, 0. Okay, so the first one, right, so here we have 3, 4, or 5 on the first one, so there are 3 options for the first digit, because we can have only 3, 4, 5, so 3 options. And then next it can be 10 for this one, 10 for this one, and 10 for this one, right? So that gives us 3,000 possible. However, we may not end with 0, 0, 0. So we have 3,000 as is. Now we have to subtract the case of 3,000, 4,000, and 5,000, because we cannot end with 0, 0, 0. So there are 3 cases of this scenario. So 3,000 minus 3, 2,997. So that's what we have. Next, simplify this factorial. Of course, if you want factorial, we will use the math, go to probability, and go to exclamation point. And that is that. Of course, we're not going to use that. Factorial meaning we start from that, going down to 11, 10, 9, and so on. But we just stop at 12, because we do have 12 at the bottom. We just cancel out, and we have 13. So that's much better. Right, a club elects president, vice president, and secretary treasurer. How many set of officers are possible if there are 15 members? To select, no person can hold more than one office. So we have president, vice president, secretary treasurer. And there are 15 members. So you can choose 15 of them. One of them can be president, but whoever that is, cannot be vice president. So there's only 14 options left for vice president, and then 13 options left for secretary. So 15 times 14 times 3. times 13, sorry. Right, so we have 2,730. Right, now there's another way to do that. There are three positions, three different positions. So the rows are different. So order matters. So that is permutation. And we choose 3 out of 15. And of course the formula for permutation, or we just use this 15 math permutation 3. Of course the same thing. By the way, the formula for permutation is n factorial over n minus r factorial. So these scenarios, it is 15 factorial over 15 minus 3 factorial. So 15 over 12. And of course if you do that, that's 2730. Next, there are 5 when running a race. How many different ways go first, second, and third place finish? Again, there are 3 different positions. Order does matter. So that's out 5. So order matters. So that is permutation. So 5 factorial over 5 minus 3. So that is 5, 4, 3, and 2. Cancel out. 3 times 4 times 5. That's 60. Of course, if you don't want to do that, you can always do using the slot like this to finish first, second, and third. The 5, 4, and 3. 5 people each. There are 5 choices for the first, and 1 will choose that. There's only 4 on the second, and 3 for third. Again, either way, we have 60. So these 2 problems, it is permutation, so order does matter. Right. Next we have these 2. Form 9 names on a ballot. Committee of 3. Now committee here, the rows are the same, so order does not matter. And when, okay, let me write this down first. Rows are the same. So order does not matter. So that is a combination. For combination, we cannot do the slot like this. But we will select 3 out of 9. Form 9. Right. So 9 over 3 factorial So 9 3 9 minus 3 6. So 9 7 9 8 7 and 6 over 3 times 6 factorial. 6 and 6 cancel out, so I have 9 times 8 times 7 over 3 factorial is 6. 9 cancel with 6, that okay. At 84. Right. Or we use this 9 math, go to probability, that permutation, combination, factorial. Of course we use combination here. Choosing 9, I'm going to pick 3 out of those. 84. Yeah. Next, how many ways we can make a committee of 3 men and 4 women out of this? Again, committee, so the roles of the men are the same and the role of women are the same. Of course, the role of all 7 are the same, but we will select only 3 men out of 12 and 4 women out of 12. This for the men, for women. So 12 men, 3, that to 10 times 12 495. Right, so that's quite a lot. 108 for 900. Right. So both of those are a combination order does not matter. Right. Let me write the timestamp. Right. The bag contains 3 red marble, 7 blue, 5 green. So total is 15. What is the probability of choosing a blue marble? There are 5 blue. 15, so that is I mean 7 blue, right? So that's 7 15. Right, we just that. A single fair die is rolled, number of die is 3 or 4. So a die, there's 6 possibility. I'm going to list on the outcome in the sample space 1 2 3 4 5 6. So there's 6 of them, and in this event we only have 3 or 4, and there are 2 of that. So the probability of getting event E of 3 or 4 is going to be 2 out of 6 or 1 out of 3. That's what we have. Our timestamp. Probability is conduct with sample space that A and B. Assume the outcomes are equally likely. List any outcome of A and B. Are they mutually exclusive? So we write A and B. So look like they have 9 and 10 in common, and those only 7, 9 and 10. And if they have something in common, so they're not mutually exclusive. Samantha taking a course in math and English. The probability of passing math is 0.4, of English is 0.6, and at least one of them is 0.8. What is the probability of passing both? So remember the inclusive and exclusive formula we did earlier. Talk about this one. If we divide by the sample space, we have the probability version of it. So we have probability of A and B, or A or B is probability of A plus probability of B minus probability of both. So in this case, we have math or English. Math, English minus both. Probability of both. We have 0.8 here. Passing math 0.4. Passing English 0.6. Minus both. We don't know x. So we solve for x. Move x there. Subtract 0.8. So we have 0.2. Yeah. So that's just inclusive and exclusive formula. Right. 27. Again, we have three outcomes. The winning is 0.4, tie is 0.5, and last is 0.1. If it's not winning, so we here's just a complement. If we want to win, probability is 0.4. So not win is 1 minus probability of win. 1 minus 0.4, 0.6. Suppose E and F are two events, P of E and F, and P of E and P of F given E is that. So we have the formula P of F given E, probability of E and F, or probability of E. Right, let's put all the numbers we have. What is the action that? So that's straightforward. Have 0.48 over 0.5. That's just straightforward here. Uh, 0.96. Right, we have that. Timestamp 28:55. The manager of used car lot took inventory of automobiles of his lot and constructed like this. Even the car select was a foreign car, what is the probability that it was older than 2 years old? Right, so it is a foreign car, so that would be out of 100 here. And so we will ignore everything else. It's a foreign car, and we will have older than 2 years old, so it have to be 3 to 5, 6 to 10, or over 10 years. So we're going to take 22 plus 15 plus 21 over 100. So probability equal to 22 plus 15 plus 21 over 100. That gives us 58 over 100. So 29 over 50. Right, so it's just that. There are 30 chocolate in the box. There are 11 filled with nuts, 10 with caramel, 9 with solid chocolate. So select one and eat. What is the probability of eating 2 chocolate filled with nuts? So that means you have the first chocolate, that is nut, and the second chocolate, also a nut. So there are 30 total, and there are 11 filled with nuts. So the first one, there's 11 nuts out of 30. But then we also want the second one. So there's only 10 left out of 29. So that's what we have. 11 times 10 divided by 30 times 29. Into one fraction. 11 for 87. So right. Next, I consider political discussion group has 6 Democrats, 3 Republicans, and 7 Independents. Suppose that 2 group members are selected. Intersection. Find the probability that an independent and a Democrat. So we have independent and then a Democrat. Right. So there's 6, 3, and 7. So the total 16. Out of those 16, we choose independent. And the first one, there's 7 independent. And after you choose the first one, there's only 15 left to be chosen. Assume we select the first one is an independent. So we still have 6 Democrats left. So that's what we have. And now we simplify this. Let's see. The only thing is 6, 16, that 8, and 2. So that gives us 14. Sorry, 3 and 2, so 21. And 8, 1/5, 120. 21 over 120. Actually, and 3 in that cancel out, we have 7 over 40. Sorry. So 7 over 40. Alright. I forgot on the review when I bring it out. There should be one more page. Sorry about that. You don't have to turn this in. I'm just going to put that on the video. You don't have to do this too, but this will certainly, this type of question will be on the test. Suppose that 1,000 tickets are sold for raffle and $3 grand prize, to $100 prize, and $100 of $1 prize. What values is the values of a ticket? Right, so I talk about the price or the values. This is the values. And then the probability. Now, there are 1,000 tickets, and there's only one of that ticket that have the values of $300. and then 2 of those tickets that have $100, and 100 of those have $1, and the remaining have no values. So there is 1,000 minus 103, 1,000 minus the winning ticket of 300, 2 tickets of 100, and 100 ticket of $1, have $897. So we just multiply for expected values. We just multiply straight across and add them. So 300 1 over 1,000 plus 100 2 over 1,000 plus 100 over 1,000. Suppose a raffle ticket they just give away, you don't have to pay anything to buy it. Right, so we just do that. Just 1, you don't need that, just 100. If I buy 1,000, that's 1 over 10. Right, you have 0.6. So they just give away the raffles and they're running the price, and then you have like the expected values is 60 cents. The same thing about expected values. We just find the values and multiply by the corresponding probability. So just like the next one, we have these values, and then we multiply by probability. Then we add all of them up. So values times probability, values times probability. Seven times 0.1 plus 8 times 0.2 plus 9 times 0.4 plus 10 times 0.2, 11 times 0.1. So that is 9. So the expected values number of customers is 9. So on average, 9 people will show up. Of course, but that's just expected. In the long run, we could expect that. But on a particular day, we could have any of this. So yeah, we just should have this part on the test as well. So with that, we finish reviewing for Math 1324. Thank you for watching, and good luck on your exams.